Hi everyone, today is part 2 of the second conic, which is ellipses. We are going to talk about a couple of extra features on the ellipse. One is called eccentricity and one is called the focus, the foci for plural. And then we're going to look at the parametric forms for the ellipse. So let's start out like we did with the circles with a review. Remember that with graphing form, there were two different versions of this based on the direction that the ellipse was shaped. So we call it x minus h, the quantity squared over a squared, plus y minus k, the quantity squared over b squared equals 1. Remember that a is always larger than b, so if the a term is under the x, this means that you have a horizontal ellipse that is longer in the horizontal direction than it is in the vertical direction. For the second version, we switch the denominators, so it's x minus h, the quantity squared over b squared, plus y minus k squared over a squared equals 1. This is for the vertical ellipse, the ellipses that are longer in the vertical direction. As I showed you in the previous video, the ellipse was made by two foci and basically a string that connects the two of those. We're going to talk more about each of the focuses, which the plural is actually the word foci, F-O-C-I. That variable is denoted by the letter C. So for both forms, to find the length C, which is the distance from the center to the focus, the formula is c squared equals a squared minus b squared. Looks kind of like the Pythagorean theorem, but it's minus instead of plus. And remember that c is the distance from the center to a focus. Now in the previous video we talked about the length, the long way on an ellipse is called the major axis and the short way is called the minor axis. There is no name for the length of the distance between the foci, but the c value is the distance from the center to the focus. So we will be using that information in a problem in just a minute. Now, the other term I want to introduce to you is the term eccentricity. E-C-C-E-N-T-R-I-C-I-T-Y. Eccentricity. Eccentricity, basically by definition, is how far from circular a conic is. How far from circular a conic is. Now, we didn't discuss eccentricity in the Circles 2 video because the eccentricity of a circle is 0. It is 0 away from being circular. So we will talk about eccentricity with all of the other conics, and I will briefly mention 3 of those 4 today. So for ellipses, the eccentricity, which is denoted by the letter E, is between 0 and 1. When E is equal to 0, you have a circle because it is perfectly circular. When E is equal to 1, you all of a sudden have a parabola. So when E is between 0 and 1, then you're dealing with an ellipse. So, and also to find the eccentricity, the formula is quite simple. E is equal to C divided by A. So you have to be able to find C in order to find the eccentricity as well. So now we're going to do a sample problem that deals with these two new pieces of information. So this example will be taking the ellipse x minus 2 squared over 9 plus y plus 1 squared over 25 equals 1. So I want to find the center. I want to find A, B, and C. And once I find that information, I'm going to be able to find the location of both of the foci. I'm going to come over here and write this down. And I want to find the eccentricity. So the center for this one, remember your rules from last time, +2, -1, insiders lie. Also remember that A is larger than B all the time here. So A is the square root of the larger denominator, which is 5. B is 3. Now, to find c, I'm going to come off to the side and say that c squared equals the larger denominator minus the smaller denominator. That's the easiest way to think of it. The larger denominator minus the smallest. So c squared will be 16. That tells me that c is going to be 4 in this case. A lot of times c squared is not a perfect square, so it doesn't come out to be a pretty value. So you may have to use decimals in this case, or even radicals, in order to define c. All right, so now I've filled out the right-hand side. I have found the center A, B, and C. Now it's time to come over here and find the foci. You need to remember that the foci are on the major axis. And the major axis is the same line as A. I'm going to write 2A because that's how long the major axis is. So what you have to do is go back and look and see which axis A is, and then you add your C value to the center for that. So here it tells me that A is 5. Which denominator was A? A's denominator was under Y. So that tells me I have to add my C value to the Y. Let me say that one more time. Since A is under the Y, and A and C are always on the same line, I must add my C to the Y value as well. So I'm going to take my center, which is 2, comma, and add -1 plus or minus 4. Now when I say add, once again, it's adding and subtracting to get both the foci. So this will become 2 and 3, and 2 and -5. There are my two foci for this problem. If they asked you for the vertices, we discussed that in a prior video. We're just focusing on the new material this time. Now for eccentricity, this is one of the simplest eccentricity formulas. E is equal to C divided by A, which is 4 divided by 5. You can write it either that way or as a decimal, which is 0.8. And yes, it is between 0 and 1. Now we're going to talk about the parametric equations for an ellipse. Now because there were two graphing forms for an ellipse, there are also 2 pairs of formulas for the parametric equations as well. So the formulas, now remember they come in pairs like they did on the circle. The first one is x equals h plus a cosine of t. Y equals k plus b sine of t. Now the difference between this and the circle, remember, is circles don't have a and b, they have just an r. So the numbers in front of cosine and sine were the same. The trick is here knowing which is which, and once we do the sample problems we'll talk about it. Now, which one do you think this one is, the horizontal or the vertical? Well, if you think about it, remember I told you that A is always larger than B. And notice here that A is in the equation with the x. So that means these are the horizontal formulas for parametric equations. Now, what's going to change for the vertical? With the vertical, the A and the B are going to switch. So for the vertical, it'll be x equals h plus b cosine of t. Y equals k plus a sine of t. Please remember the words cosine and sine never switch. X always goes with cosine, y always goes with sine. We'll talk more about that once we get to the trigonometry unit, but for now, just remember that they must stay where they are. Because A is with the y, that means that this is a vertical ellipse that goes this way. And I'm going to write down out to the side, remember that A is always greater than B when it comes to conversion between the two. The directions here will be write in parametric form. Our equation is going to be x plus 6, the quantity squared, over 4, plus y plus 2 squared over 49 equals 1. When we did the parametrics with the circles, we wrote down the pertinent information out to the side, and then we were able to write our formulas down. So I'm going to do it this way. I'm going to need h, I'm going to need k, I'm going to need a, and I'm going to need b. H and K are pretty straightforward here. H is -6, K is -2. A is the square root of the larger denominator, which is 7, and B is going to be 2. Which kind of ellipse is this, horizontal or vertical, and why? Think about that for a second. Which one is it and why? Can you answer that question? The answer is, it is a vertical ellipse because the larger denominator is under the y. So I'm going to be using the formulas for the vertical ellipse, which is the bottom set. So our formulas will be x equals h, which is -6, plus b, 2 cosine of t, y equals k, -2, plus a, 7 sine of t. Now let me point something out to you to kind of help you see how this works together. Notice that the y and the 49 are in the same fraction. Come down here and look at the parametrics. Notice that the y and the 7, which came from the 49, are in the same equation. And that will hold true every time. So instead of having to worry about two different formulas, if you can just remember that the denominator's square root goes in front of the cosine or sine based on what letter you're working on. So my x equation is going to have the -6 because that's part of the x fraction, and it's going to have the square root of 4, which is 2, right there. The y equation is going to have the -2, which was the k value, and the square root of 49 in front of its sign. So that's a really quick way to think about it if you followed what I just said. If that was a little too quick for you, just use your formulas. You can use the formulas, but you've got to remember that you need to look at your problem to determine whether it's horizontal or vertical to make sure you put all the numbers in the right location. All right, today is also a Griffith-only assignment because this material is not covered in the Delta textbook. So for the Griffith book, this is going to be section 1.4, which is page 12, and you can do either the odds or the evens, whichever you prefer. All right, that's it for this lesson. Good luck, and let me know if you have any questions.